Hey guys, in this video I'm going to be going over 1's and 2's complement. Let's start off by looking at 1's complement. So 1's complement pretty much means that you invert any given bit. So let's just start off with a basic example. Let's just say 1 bit. So let's say we're given 0 as our bit. If you're to invert 0, 0 will become 1. And also, the same applies for 1, except instead of it becoming a 1, it becomes its opposite, so it's going to become a 0. Keep these simple rules in mind, because these rules will be important as this lesson goes on, and you'll see what I mean exactly once I start working out some examples. So, given that we know how to, make something into its complement, let's look at a real binary number. Say we're looking at the following binary number: 1 0 1 0. If you were to invert this and make this into its 1's complement, then it would become this number. It would become a 0 1 0 1. So this right here is the 1's complement of the above number. And just for the sake of another example, let's just work out another one. Let's say you had something like 1 1 1 0, and you want to find the 1's complement of this. So you invert every bit, and it'll become 0 0 0 1. So the 1's complement of this above number is here in this red box that I just drew up. Okay, now let's quickly talk about 2's complement. 2's complement, in order to get the 2's complement, you need to get the 1's complement first. So for example, let's use the number we had before. The one that let's use this number. This will be a pretty straightforward example. So keep in mind that the 1's complement that we had is here in this red box. So it's this 0 0 0 1. Pretty much the 2's complement, and here, let me just write it out real quick. 2's complement, and I'm gonna just abbreviate it and leave it at this. 2's complement, you pretty much take the 1's complement and you just add 1 to it. Okay, so given the number that we had before, and I'll just write it out, we had a 0 0 0 1. Let's assume this is our 1's complement. So if you were to add a 1 to this binary number, and if you don't know how to add binary numbers yet, please check out my other video, but for the sake of, proving a point here, I'll just go through real quick. So we add a 1 to this, so then this 1 will carry over, and then it'll be this. So this right here will be our 2's complement. Now, as far as, why I'm showing you 1's complement and 2's complement, the reason why I'm showing you is because this will lead into being able to subtract, 2 binary numbers. I mean, you can, in fact, actually subtract binary numbers, just, like straight up as you would decimal. For example, you can, do something like this. But this is how you would do something on paper, and after a while, let's say you're trying to understand exactly how, let's say, a computer does it. A computer doesn't subtract 2 binary numbers in this fashion. It's gonna add 2 binary numbers in order to subtract it. And if you were to add, in order to subtract, like, let's say the same thing, you would just have to add, this. Oops, sorry. You'll just have to add this. Binary numbers like negative equivalent. You'd make this negative, and then you would add it, to this above binary number, and that's essentially the same as subtracting it. So let me just show you some examples really quickly using the ones complement and then using the twos complement. Okay guys, let's go over an example using ones complement. Let's say we want to take binary, 15, and let's just say we want to subtract it from binary 5, for example. So binary 5 would be this. If you were to subtract binary 15 from binary 5, you should get binary 10, so that'd be 1, 0, 1, 0. So let's see what exactly we'd have to do in order to subtract this using ones complement. So in order to subtract this, we're going to have to take this number here, because we're trying to subtract this from the above number, and we invert all the bits. So let's go ahead and do that real quick. So 0, 1, 0, 1 is going to become 1, 0, 1, 0. Okay. Now let's just keep this in mind, this ones complement number, and I'll just write it over on another slide, I guess, so it's easier to see. So we had 1, 1, 1, 1, 1, 0, 1, 0, and essentially you're going to add these together. So we have, starting from the far right, we have 1 plus 0, 1, 1 plus 1 is going to be a 1, 0 with the 1 carried over, 1 plus 1 is going to be 1, 0 with the 1 carried over, and then this is going to be a 1 with a 1 carried over. And this one that just carried over, this is referred to as overflow. And when you're doing, when you're trying to subtract using ones complement, this number here, you essentially, whatever value this is what you're going to add on to this number right here. Let me try to get I guess a different color. So you're going to actually just try to add it on right here to this number. So if you were to add a 1 to this number, let's just write it right here. If you were to add this 1, it becomes a 1, 0, 1 carries over. And if you know your binary, 1, 0, 1, 0 is in fact 10, so 15 minus 5 is 10. So this result that we get here on the bottom is the correct result we wanted. But in terms of which one is probably easiest to do, you'll see right now that twos complement is a lot easier to do. And I guess the reason being is because with twos complement, you already have the one added on. From the ones complement, you add a 1 to the ones complement. So here, let's just work out this same example, but this time we'll do twos complement. Okay, so we already know that twos complement is you find the ones complement of the number that you're trying to get the twos complement for, and then you just add a 1 to it. So the number that we need to add a 1 to is the number 1. Oops. Is the number 1, 0, 1, 0. So essentially, if you add a 1 to it, it's just gonna pop up right here. So now that we know this, let's just go about the math for adding binary 15 with this number. So I'll just go on another slide. So we have 1, 1, 1, 1, and then with this number here, 1, 0, 1, 1. So 1, 0, 1, 1. Add them together. 1 and 1 is a 1, 0. 1 carries over. This 1 and 1 is a 1, 0, but then you have a 1 that adds on, so it's 1, but then with 1 carried over. 1 and 1, let's see, 1, 0, 1 carries over. And the same thing here, where there's a 1, 0, but then there's this other 1, and then the 1 carries over. Now, with 2's complement, as you can see here, there's this extra bit that got carried over. So, this can actually just be ignored. And the result that we actually wanted is right here. So 15 minus 5 is 10, and this right here, the 1, 0, 1, 0 is 10. So I mean, in terms of which one is more commonly used, 1's or 2's complement, I guess it depends on the situation and which what it is you're trying to do. But in terms of computers, I believe 2's complement is the one that's primarily used, because with 2's complement you can actually have signed, you can have a signed bit. And when I say signed bit, I mean you can distinguish either it's positive or it's negative. So just keep in mind everything that I laid out here today. Just remember, with 1's complement you just invert all the bits. And then with 2's complement, you want to make sure you have the 1's complement, and then you just add a 1. You add 1 to the 1's complement, and then I'll give you the 2's complement. And this is essentially how computers add binary numbers. So I hope this lesson was helpful, and I'll just end the video here for now. I'll probably come out with some other examples in the future. If anybody requests it, or if there's any confusion, then I'll be sure to do that. And please let me know if anything I'm stating is invalid or false. I mean, keep in mind, guys, that I'm not necessarily just winging the video, but a lot of this information I'm kind of recalling it from things I've done in the past. I've done stuff with circuits and computers and all that stuff, and I'm trying to recall this information as best as I can. I mean, I do some research beforehand, so that way I can verify that what I'm telling you is in fact mostly correct. But if I do make mistakes, please let me know. Just like you're here to learn, I'm here to learn as well. But with that note, before the video gets any longer, take care, and be sure to comment and subscribe if you like. And if you like this video, please like it, and catch you later, guys.